Hey guys, so I'm just going to do a Unit 8 review with you so that you remember what it is that we did in Unit 8 so that you're better prepared for the test. So remember to use the cheat sheets that I provided to you for this test because they will truly help you out with each one of the questions. So it's going to be 14 questions long. This review is just like how it will look on the test. So the first question is, given an equation, you have to graph the function, and these are all parabolas, so we know we're going to make a parabola. And with this one's in a form where it's a is the number that's out front of the x squared, ax squared, and this is c. So this is like in the form ax squared plus c. So if you recall, the vertex for this, or our starting point, is 0, c. So in this case, since c is positive 2, our starting point where we start our vertex is 0, 2. So on my graph, I'm going to plot a point at 0, 2, and that's going to be right there. Okay? Then from there, remember the pattern with parabolas in graphing is moving right and left 1, and then up or down 1 times whatever the A is. And the same thing with the next set, you move right and left 2 spots, and then you move up or down 4 times whatever the A is. Remember, the pattern is 1 and 4. So since our A is -3, we need to figure out how we're going to move up or down, how many spots we're going to move up or down. So 1 times -3 is -3, and 4 times -3 is -12. So you're going to start at that spot and you're going to move 1 right and 3 down. 1, 2, 3. And that's going to be your first point because remember, the negative tells you to go down. Okay? And then you're going to move left 1 and down 3, and you're going to plot another point. Then you're going to move right 2 and down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 would be about there. And again, left 2 and down 12. So your last point would be there. And then you're drawing your best parabola that you can draw. Although on ALEKS, this will be a little easier because you'll be able to plot it using the tools that they give you. Okay, and then that's how that parabola looks. So the next question on the test is going to be in this form. And this form, if you look at the cheat sheets, is x minus h all squared plus k. Now for this form, the vertex that you have to find first is h comma k. Okay, so in this equation, if there is a minus sign on the inside of the parentheses, then the h is +1. And a plus sign on the outside of the parentheses for the k means that your k is +2. So that's our starting point. We're going to plot 1, 2. So you plot that, and that's our vertex. That's where we start our parabola. And we're going to follow that same pattern of 1 times whatever a is and 4 times whatever a is. So in this equation, the a is on the outside, okay? So we need to know if there's nothing on the outside, then our a is just 1. So in this case, we're going to multiply 1 times 1 and 4 times 1. So 1 times 1 is easily 1, and 4 times 1 is easily 4. So it's just going to be your regular setup of a parabola. Since a is 1, it's going to go up because it is positive. Okay, so remember that. So we're going to go right 1 from that starting point and up 1. And then we're going to go left 1 and up 1. And then we're going to go right 2 and up 1, 2, 3, 4. And left 2 and up 1, 2, 3, 4. Remember, it's that same pattern every time. 1 times whatever the a is and 4 times whatever the a is. And then you graph the parabola. Okay? So number 3, question number 3 on the test is going to look like this. It's another graphing of the parabola. But this time it's in your regular quadratic equation form, which is ax squared plus bx plus c, which we've done a lot of work with these past couple days. So for this form of parabola, remember there's something a little different that we have to do to find the vertex. We have to do a little bit more work. In this one, we have to use the equation x equals negative b over 2a in order to find the x. So in this one, we have negative, and our b is negative 2, so I'm going to put parentheses there, divided by 2 times a is 1, so it's just 2. So we have positive 2 divided by 2, which is 1. So far, our vertex is 1, comma, and I don't know what the y is. I need to figure that out. So we figure that out by plugging it in. So plug it back into the equation. So we have y equals, x is 1, so 1 squared minus 2 times 1 plus 4. 1 squared is 1, minus 2 plus 4 is, 1 minus 2 is negative 1. Negative 1 plus 4 is 3. So now we just found our other coordinate in our vertex. Now that we have done the work to find the vertex, we just need to plot it. So 1, 3, you're going to plot on your graph right about there. And then you're going to use that same pattern that we've been doing for the previous ones. Since our A is 1, it's going to go up. And you're going to be going 1 times 1, which is 1, and 4 times 1, which is 4. So you go right 1, up 1, left 1, up 1, right 2, up 1, 2, 3, 4, and left 2 and up 4. And then you can make your parabola. Okay, so remember that all of these graphing of the parabolas all follow that form where you go right and left 1 and up 1 times whatever the A is, and right and left 2 and up 4 times whatever the A is. So question 4 on your test is to solve an equation. So this is the last couple days that we've been talking about where we have to actually get an answer, like x equals these two things. And usually it is 2 solutions about. Sometimes it is 1. So to solve the equation by graphing, we need to graph it first, and then we need to identify what the 2 points are on the x-axis. So in order to graph this, just like we did in the previous problem, we have to do x equal negative b over 2a to be able to graph it, okay? We got to find the vertex. So remember A, B, C. So the b is negative 2, so you got negative, negative 2 all over 2 times a, which is 2. So in this one again, 2 divided by 2 is 1. So our vertex is 1, comma. And if we plug it back in, we've got 1 squared minus 2 times 1 minus 3. So 1 squared is 1 minus 2, which is negative 1, minus 3, which is negative 4. So our vertex here is 1, negative 4. So we're going to plot 1, negative 4. Okay, from there, since A is 1, it follows the regular pattern, and it's going to go up. We're going to go right 1, up 1, left 1, up 1, right 2, up 1, 2, 3, 4, and left 2, up 4. And if I draw my parabola in ALEKS, then I can now name what my 2 solutions are. So my 2 solutions for this one would be x is equal to negative 1 because it hits negative 1 on the x-axis, and x is equal to 3. Those are my 2 solutions because they hit at negative 1 and 3 on the parabola. Okay, so that's how you do question 4 on the test. Question 5 is a little simpler because question 5 is already factored out. So you don't have to do the factoring this time. All you have to do is set each of the factors equal to 0. So for number 5 on the test, you're going to say 5w plus 9 equals 0 and 3 plus w equals 0, and you're going to solve each of those so that you have, again, 2 answers. So this one's going to be a fraction. We're going to minus 9 from both sides. We have 5w equals negative 9. Divide by 5 on both sides, and one of our answers is w is equal to negative 9/5. Okay, And then for this one, I'm going to just simply subtract 3 from both sides. And in this one, you're going to get W is equal to -3. So 2 answers there. Just set each piece equal to 0. In number 6, you have a little bit more work because you have to factor first. So question number 6 is really where you start to see the factoring come into play. So you have to take out what they have. So take out that GCF that they have in common first, okay? They both share a number 4. They also both share a W. So I'm going to take out a 4W here. And what I have left is a W plus, if I take out a 4 from 20, I have 5 left over, and then there's no more W's left. So right now you have 4W times W plus 5 is equal to 0. And your last and final step with all these to find a solution is to set each piece equal to 0. So 4W equals 0 and W plus 5 equals 0. So in order to solve the first one, I'm just going to divide by 4. So easily enough, W equals 0 is one of our answers. And in the second one, I'm just going to minus 5 from both sides, and W equals -5 is another one of our answers there. Similar to the last question, we are going to be doing factoring again in numbers 7 and 8. So we're going to factor these out based on what we learned about factoring in the previous unit, okay? So remember, when you're factoring a quadratic like this one, like this example, you're trying to find factors of 20 that add or subtract to get you 9. So 2 factors of 20 that add to be 9 would be 5 and 4. So I set up my parentheses, open up my 2 sets of parentheses, put V at the front, 5 and 4 at the back, and then if I want to refer to my factoring cheat sheet, a minus plus is going to be 2 minuses. And now that it's factored out, I'm not quite done. My last step is I have to set each piece equal to 0. So you have V minus 5 equals 0 and V minus 4 equals 0. Add 5, V is 5 for one answer. Add 4 and add 4, V is 4 for the other answer. So there are your 2 answers for that one. Okay, so factor first. In the next one, we have to get it equal to 0. So we have to add the 26V onto both sides first. So we have, and let's see if I can separate it a little bit. So we have 5V squared plus 26V, and we want to keep it in that same form where it's a V squared, a V, and a number, plus 5 is equal to 0. And now you're going to do your factoring, but in this case, we're going to use the Berry method. So remember, you take 5, let's see if I can highlight it for you. So remember, you're going to take this 5 times this 5, A times C. So 5 times 5 is 25, and you're going to find 2 factors of 25 that get you 26. Well, to get 26 easily enough, 2 factors of 25 would be 25 and 1. So then you're going to lie according to the Berry method. So you're going to set up your parentheses, and you're going to start each set of parentheses with 5V, because that's what you started off the equation with. And you're going to end it with your 2 factors, 25 and 1. And this is going to be a plus plus because of the symbols. Then you look to see if you can take anything out of the first. So the first one I can take out of a 5, and the second one I can't take anything out of. So I'm just going to take it out of the 5, and then I'll have my answer. So if I take 5 out, I'm left with V plus 5 and 5V plus 1 equals 0. Again, you're not done quite yet. You still have to set each piece equal to 0. So for this one, to get our final answer, we're going to say V plus 5 equals 0 and 5V plus 1 equals 0. Minus 5, V is -5. There's one answer. Minus 1, 5V equals -1. Divide by 5, and V is going to be a fraction here. -1/5 for your other answer. Okay, so those couple questions, 6, 7, and 8, are going to take you a little bit more work because you have to do factoring first. Question 9, if you can see it around all of these. So question 9 is dealing with the square roots, okay? So here's question 9, dealing with the square roots. All they want you to do is solve x squared equals 81. So the only thing that you have to remember about this is that the square root property says that you have two answers. So when you square root it, when you square root both sides, the square root of 81 is a perfect square, so it is 9, but your answers are positive 9 and negative 9. Okay, so you have to make sure you put both answers down. In question 10, it's very similar to question 9, except for the fact that it's not a perfect square this time. So this time, instead of giving a whole number answer like 9 and negative 9, you're just going to simplify the radical. So watch what happens here. You have x squared is equal to 75, and you're going to square root both sides. Well, 75 isn't a perfect square, but it can be broken down into the square root of 3 and the square root of 25, because 3 times 25 gets you 75. And 25 is a perfect square, and that happens to be 5, and it's plus or minus, right? So that tells you that your answer is simplified in square root form. X equals, you keep the 5 on the outside because it got taken out because it was a perfect square, and then you keep the square root of 3. So 5 square roots of 3 is your answer simplified form. And don't forget, negative 5 square roots of 3 is your other answer because you have to have a positive and a negative. All right, so that's the square root function. Still sticking with the square root function for question 11. So you're going to have 3 square root functions in a row so that you won't get too lost. So we're right here on question 11. So question 11 says that it wants you to solve it when it's like this. You're still going to follow the same routine. So you're going to get the x minus 3 squared by itself first. So if I write it over here, I'm going to write it in black here. X minus 3 squared minus 32 is equal to 0. My first step is I'm going to add that 32 so that I can get the x minus 3 squared by itself. So I have x minus 3 squared is equal to positive 32. Then, to get rid of a square, I'm going to square root like I did in the previous two problems, okay? And when I do that, I'm going to get x minus 3 left, and the square root of 32. We have to think about perfect squares that would come out of 32 to simplify it. And it just so happens that 16 times 2 is 32. So this can be broken down into square root of 16 and the square root of 2. But the square root of 16 is 4. Okay? So when we rewrite this, let me give myself a little bit more room. When we rewrite our equation down here, we have x minus 3 left because all I did was get rid of the square equals 4 square roots of 2 and negative 4 square roots of 2. Always two answers there, a positive and the negative, okay? Then my final step will be just to get x by itself. And so I'm going to add 3 to all three equations. And when I do so, I now have my 3 answers, and I'm just going to write them up here. My 2 answers, so I'm just going to write them up here. So you have 4 square roots of 2 plus 3, comma, negative 4 square roots of 2 plus 3. Okay, so you're going to have simplified radicals in question 11 that you're going to have to break down into perfect squares. And then question 12 through 14 is the last couple days that I have done with you guys, okay? And it's definitely using the quadratic formula for question 12 and 13. You have to use the quadratic formula, okay? And so this takes a lot of scratch work. So you don't have to memorize the quadratic formula. I did give it to you in a cheat sheet. So as a reminder, I'm going to write it down here. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. That's a reminder down there. So for question number 12, we're going to do that one first. This is a, this is b, this is c. So we're going to plug it in. X equals -9 plus or minus the square root of 9 squared minus 4 times 2, which is A, times 5, which is C, all over 2 times A, which is 2. Okay, so let's simplify it a little bit. We have -9 plus or minus the square root of 81 minus 4 times 2, which is 8, 8 times 5, which is 40, all over 2 times 2, which is 4. So this becomes -9 plus or minus the square root of 41. 81 minus 40 is 41, all over 4. And for this particular one in Alex, they want you to keep your answer just like this. So if they don't ask you to round, you're just going to keep your answer just like this. So your answer for number 12 would be -9, I'll write it up here, plus the square root of 41 over 4, comma, -9 minus the square root of 41 over 4. All right. Number 13 is similar. You still have to use the quadratic equation. In number 13, though, let's see, I'm going to highlight the quadratic here. In number 13, we're just using different numbers. We do have to make sure we get that -2 over first. So I'm going to do that just by adding it. And so your equation should really look like 5x squared minus 9x plus 2. So remember, A is 5, B is -9, C is 2. So let's plug it into the formula again. So we have x equals negative b is -9, which would just be +9. So I'm just going to write that as a +9, plus or minus the square root of 9 squared, which is 81, minus 4 times a is 5 times c is 2, all over 2 times the a this time is 5. So we have 9 plus or minus the square root of 81 minus 4 times 5 is 20. 20 times 2 is 40. So this looks very similar to the previous one, all over 10. And we have 9 plus or minus the square root of 41, all over 10. It does look similar to the previous one. However, this one does ask you to round to the nearest hundredth. So remember, you're just going to put that in the calculator. Okay, and if I put it in the calculator, then I'm going to write my answer in red. My two answers here are going to be 9 plus, I'm going to punch in the square root of 41, and then I'm going to divide that by 10, and I'm going to get 1.54 in the calculator, and you can use the Alex calculator on the that they provide you to figure these out. And then I'm going to punch in 9 minus the square root of 41, since I have to do the plus and the minus, and divide by 10, and you should get 0.26. And those are your two answers for question 13. Question 14 is the last one that we did, and it's the discriminant one. Pretty easy, straightforward. Remember, you don't have to remember this by heart, but the discriminant is b squared minus 4 times a times c. And remember, you have a, b, c right on top of here. So when we plug it into the discriminant, we should get -9 squared minus 4 times 4, which is a, times 1, which is c. And you get 81 minus 16. 81 minus 16 is 65. That's our discriminant. And since 65 is greater than 0, we know we have two real solutions. And I did create a cheat sheet for that one as well. All right, so you can use this review as practice for the test. You can look over it. You can try your own review practice and then take the test on Alex. All right, good luck.